Okay, so last week we used the 3D modeling tools within Vcarve to create the bowl. And we added some tabs, we added the hearts, we created the two sides to it. Tonight I want to take it a little bit further, but first we'll just do a little bit of review from last week. You remember last week after we created the bowl, we went in and we played around with it a little bit, and we ended up with this custom design. And I talked about how, the hearts are being a little weird here. They're overlapping. We had that little weirdness of the edge, and that there's probably some ways to deal with that. A couple of you emailed me to mention to me about, kind of like reminding me about the 3D molding toolpath, which is actually a really good option for this. I didn't include that just because I was trying to stick to the 3D modeling. But on that note, I did go back and rework this file, and you can see there the comparison now. I readjusted the location of the hearts, and I gave it a nice even rounded rim all the way around. And that rim you see here is actually not a 3D model. That's strictly a toolpath called the molding toolpath. And the molding toolpath takes advantage of a vector and a cross section of how you want that molding to look, and then you have the molding toolpath set up. That's the essence of it. I'm not going to go into detail of this tonight, but in a couple of projects, probably, let's see, we're coming up in February, probably March, I have a project plan that will actually be using the molding toolpath. So then we'll take a close look at how to use that to create like something like we just for this rim, or for other types of shapes where you have a profile and you want it to follow a line. It's a pretty powerful toolpath. It is, however, very different than 3D modeling, and you kind of have to understand the difference between the two. Also, for a project like this, custom 4-part dish like this, you have to do a little finessing to get the two parts to time out or to match up with each other. And we'll take a look at that as well when we do the actual project on molding toolpath in a couple of months. Coming up next month, talk about what's called the inlay toolpath, the pros and cons of how to use it. It's pretty simple. It does a lot of the work for you for creating what I call a name puzzle. And that'll be the project we'll be working with. But there are a few things to understand about how it works that once you understand a couple of those tips and tricks for making it work, you'll get the best results out of it. But it's a fun toolpath, not only for doing something as simple as a little name puzzle, but sign makers use this. The big strategy there, if you're doing a large sign or even a medium sign, let's say, and you cut out some of your parts separately, it allows for finishing so much easier, because then you could color these letters all different colors. You can paint the background and literally put it together like a puzzle. And for sign makers, this becomes a very powerful tool if they're dealing with either different materials, but particularly for the finishing standpoint. So a lot of advantage to using that. It does not give the kind of inlay tightness that you might see with something like a Vcarve inlay. It's more of a puzzle fit. So you do end up with a little bit of a glue space around it. And it's not really intended to be an inlay like wood inlay. I know some people have used it for that and try it, but because you have that vertical edge, you have to have a certain amount of clearance in order for that to fit. And when you have that little bit of clearance, you do end up with a little bit of glue gap around the edge. So it's not maybe the perfect fit that some people like it to be, but it's actually not intended. It's more of what I like to refer to it as a puzzle fit with a little bit of gap, but the results can be pretty nice. Okay, so next up, tonight we're going to be talking about the toolpaths for the bowl. And to start right off, let's take a look at this. These 4 bits are the ones that I used to create this actual bowl, the actual real one that ended up in the Project of the Month article. The straight one, the quartered straight bit, was used for roughing out the inside of the bowl and the back of the bowl, as well as cutting the registration holes in the front. And then this little 1/8 inch bit was used for doing the heart side after I roughed it out with the 1/4" bit. And then the 1/4" Ballnose was used on the bottom side. Because there was so little detail, I was able to use the 1/4" bit on the bottom side for the finishing pass, and I did not need a finer bit than that. And then the little V bit was used for the engraving on the bottom side. Now, I've got emails from people. There's a big discussion about like what bit to use under what situation. Generally, I suggest people use as short a bit as you have available. And the rationale for that is, first of all, it's less likely to break. There's less flex or chatter created by an extra long bit. Also, if you're not using all this cutting edge of the bit, it's just kind of wasted carbide. Now, with that said, you can see here on the right, here's like 3 different styles or 4 different styles of 1/8" bits. You've got a stubby bit with about a 1/2 inch length, which is pretty much what the bit was that I use. I've got a 1/2 inch because I'm not cutting very deep with it, so I don't need a long one. But I also have all 3 of these bits as well. And this one with the straight one, of course, is the most fragile, and that's the one you have to watch out for. So I don't use that style much anymore. Most of them are a tapered bit, and the taper adds a lot of strength to the shank. And so when you have a chance, if you have deep carving to do, then these tapered bits make a lot of sense. Now, sometimes you need this length just to get down inside a deep carving. Other times, as we'll look later tonight, when we go to the toolpath, this extra cutting edge actually provides some advantage as well. And we're going to talk about those different aspects of that. One other thing I want to look at tonight is we're going to be talking a lot about what kind of results you get with different bits and different settings. And this is just kind of a quick peek at, 3 different bits relative to the standard step over that I use for most 3D carving is 5%. Now, I used to recommend it with a kind of a standard default setting of 7 to 11. I always tended to err on the 7 or 8% side. But the more I've done 3D carving, the more I find that even though it increases the time quite a bit, that the 5%, especially when it's a difficult to sand item, it takes more time, but you definitely do get a smoother finish with the 5%. Now, I know some guys who go pretty wild about this and have dropped it all the way to 2%. But what you're going to see tonight, if you haven't tried this, is you're going to see that every time you drop down a percentage, you're adding a lot of carving time. And I carved this, the inside of the bowl was carved with the 1/8" bit, and the bottom side was the 1/4" bit, both using a 5% step over. And I probably had, I don't know, a half hour to 40 minutes worth of sanding maximum. I went into this inside with hand sanding and sanded out. Had a little bit of mill marks from that 5% step over the 1/8", and got that sanded out. And to the bottom side, I was actually able to use my power sander, disc sander, or rather orbital sander to do the bottom. So less than an hour of sanding. If you drop this down to a 2%, you're going to probably add more than an hour of machine time, and you still probably have to go back and sand. So much of it depends on the type of material that you're cutting, and so some testing is always recommended there to see what the results are like. But you can definitely reduce sanding by going down on the step over. But the further down you go on the step over, the smaller the step over, the more time you'll add to your machining. So it's always a compromise. It's also worth pointing out that, paper is about 5,000 thick, and 200 grit sandpaper, or 220 actually, is about 0.003. So you can see right there that that's the equivalent of the step over on the 16" bit. I mean, all these are going to require a certain amount of sanding, especially for something like a bowl where you want it smooth. But there are some 3D carvings where you either can't get in there and sand, or else you don't need to, depending on what you're trying to do with them. So it's kind of a personal choice there. But just to kind of size things up, give you a comparison. So tonight we'll be using the 5% step over for all the machining, but I will show you the effect of the other step overs if you decide to go up or down on that. Now, before we actually jump into the toolpath, I did want to touch on something with two-sided. Now, we didn't lay out the spoil board or the registration holes last week, but they're pretty basic. They're just laid out in the four quarters, all basically in the same. Let's see if I can select one here. There, we got that one. Let's look at what the setup on this is. If I look at the position of this, and we take the center of it, so let's see here. Let's go with it like that. Okay, all right. So these two are grouped. Let's ungroup those. There we go. So you can see here in the upper left at that location, it's a -3, +3, because we're going off the middle of the board. If I select this one, we go, that's grouped as well. Here we go. That's 3 and 3, and then we just go around and it ends up being a 3-inch offset all the way around. Now, I have all of these set up on this one side. For some two-sided setups, I'll put registration holes on the other side, but you never actually drill, or you generally shouldn't need to drill or route registration holes at both sides of your board. Typically, you will only do registration holes on one side, which is typically the side you carve first, and then you put registration holes in your spoil board, and those two mate with each other. So in this case, that's why we have these blue ones, the registration holes on the top side of the project. Once I drill those out, and then I put the spoil board registration holes, when this board flips over from right to left, this hole is going to line up with that hole, and opposite, this one will line up with the other one. So that's why you can easily lay them out on one side of your project. They don't have to be laid out on both sides. But I've done it both ways, but that's just how I'm doing it on this one. Stepping back one step before that, if we look at the job setup, again, just reviewing what we looked at last week, the basic setup here is you're going to click on double-sided. You're going to set up your material side, material surface for your Z-zeroing. So whichever the front or the bottom, the top or the bottom of your project, you're going to zero off the top for your Z0. So with your touch plate, you put your touch plate on the top of that. That's how this is currently set up. This is the best way to set it up if your material is consistent in thickness. I was using 1.5-inch material that had been planed to exactly 1.5 inches, so that worked out well. If you have the option of also doing it to the bed, but the material surface is probably what most of you are familiar with, and it generally works just fine. Now you have this other option here off the same side, and so what that means is you set it up, zeroing it off of side one to start with. Then when you flip it over, you zero it off the bed, which is the same as side one. The reason for doing that would be, if you, as I mentioned last time, if your material is a little uneven in thickness, rough sawn or something like that, or maybe it's not exactly 1.5 inches, by doing it this way, you end up letting that extra excess material or uneven material go to the other side, and it evens it out then. So you actually have you're always measuring from the same surface. Zeroing, I generally like to do it right in the middle for this type of setup. And then for this one, you could pick either forward or back or in the X direction. I like to typically flip it left to right just because everything reads that way on my machine. So that's the basic setup of it. When it comes time to actually route the holes, like I said, we'll be using that straight bit. So with that, let me open up the toolpath side of this. I already have the toolpath set up for this, so we're going to take a look at these individually. Now, something you'll notice here is that my registration holes on the top and registration on the spoil board, I have a whole list of them. Now, the reason I do this, and you'll have to take a look at the instructions for little more detail on this, but I use PEX tubing. It's just supply line tubing, like for a sink or a toilet. It is 1/4 inch inside and 3/8 inch outside diameter plastic. I like it because it's really cheap. It cuts easy. It's not going to harm my rotor bits if I run into it. And if my vacuum sucks it up, I can just cut another piece. And it's also nice because these holes, which are around 3/8 of an inch diameter, I can easily route those out with my 1/4 inch bit. So that's my chosen material because it's very consistent in diameter and it makes a nice material to work with. However, depending on the kind of material I'm using and which of my straight bits I'm using, I have found that I typically have to oversize the hole by a little bit. So rather than going back to my computer every time and creating a new tool path every time I'm trying to set one of these up, I have this group of tool paths set up that are increasing, as you can see, in diameter. Now, the way I set these up is I start out, we'll open this one up first, is that I would select my two holes like that. And I'll just group those again. Mm-hmm. And I'm setting my cutting depth. Now, my pins are about 1 inch long, so I'll go 0.6 deep just to make sure I have plenty of clearance for my pin to go in there. And I'm cutting on the inside. Nothing's, unusual in this setup. 0 allowance offset. We'll come back and look at that in a little bit. And then I just simply calculate it out. And I name it 0.375 because that's the actual diameter of it. I'll go back to 2-dimension here for a minute. If I turn on my preview up here, my solid preview, and highlight my tool path on the right side, make it visible, there you can see where it's cutting, that light blue area. Now notice when I click on the next one, how it gets slightly larger and larger and larger. So I'm increasing by that small amount. What I do is after creating that first one of 375, I actually use this tool right here, which is called duplicate the tool path. And I click on it like that. And it creates many duplicates of it, as many as I need. And then I would go into this one and we'll take this one. It's actually done already. But that starts out with all the parameters that are the same as the original one, the same vectors, everything about it are the same. But inside it, notice that I've added some offset allowance. Let's close the rest of those and zoom in on this a little bit. There you can see that little bit of offset. And so that allowance, you can do the math, so you can increment this up however much you want. What you need to understand about the offset allowance is that when you have it set to inside, the offset allowance increases the inside setting of it. So if that's why I have to go negative, because negative puts it outside the line. If I gave it a positive offset, notice what it does. Go like that. Go back to the 2D view. Notice how it goes to the inside. So by default, this offset allowance moves, if you use a positive number, it moves in the direction that you're set up. So we're on the inside, it'll move it further to the inside. If I were cutting to the outside, a positive offset allowance would move it further to the outside. So if you want to move it to the opposite, which we do in this case, simply add a negative, and that'll move it to the outside of the line a little bit. Recalculate that, go back, and then we moved it to the outside. So all of these tool paths now are set up, as you can see, incrementally growing. Now that may seem like a lot to set up, but once you have these set up, you can reuse these in other setups. So I typically just transfer these over then to another tool path or to another project, or I'll just take this project, rename the project, delete all my other vectors out of it and just have all my tool paths here that I used on my last one. So there's lots of ways that you can deal with duplicating these. Let me delete these extras. So there we go. So that I set up all of these. And you can also take, and if you haven't used groups, to create a group, just take one of the headings right up here, or actually, let me take this one down here, and I'm going to say create empty group, and it inserts it right there. Now, if you want to move that group around, you can move it up or down like that, wherever you want it. And then inside that group, since the group is highlighted, you're able to add toolpaths inside that group. The other thing you could do, which I did in this case, is I selected that group and I went in and I hit duplicate. And so notice now I have registration holes top and I have a whole set down here, which are all duplicates. So I was actually able to take this set, rename it, reopen each of those tool paths and associate it with the other set of holes. So I save myself a lot of time in setting up new tool paths, still a little bit in there in recalculating it, but it saves a lot of labeling. It just saves a lot of time. So there's a lot of convenience to doing it that way. Delete that group. The other advantage of groups is that I can shrink these up if I start getting a lot of tool paths, and I can just deal with the ones I want to deal with. Now let's take a look at more detail at this registration hole. This is a pretty basic setup. Most of you have probably done things like this with either cutting or drilling holes. But we'll take a look at the tool bit itself. Now, depending on which tool you have set up, I actually have this one. Notice I've actually added a label. In fact, I wonder if we can look at it inside the actual tool database. There we go. So switch this out here. So that's called end mill slow. Now, the reason I have that set up and called slow is because notice how, and that's actually not quite set up correctly. Good thing I checked it. For my uses, when I have a bit set up that says slow, that means I'm typically in the 30 inch per minute range for both the feed rate and the plunge rate. And this is the speed that I typically use when I'm routing small holes like for the registration. If you go faster than that, the machine it can chatter, sometimes acts a little like a sewing machine because you're moving it just too fast. It might be, comparable to going 60 miles an hour around a roundabout. It just doesn't work that well. So I'll set up a dedicated tool. All these quarter-inch bits are probably the same bit. I just have them set up with different ranges of speed so I can quickly grab them. And then to rename them, I just go under here and I just manually, this is all the automatic coding, but I just manually type in slow. And then I've got my own bit set up like that. And then my different pass steps and such. Now, again, you'll have to play a little bit with what kind of material you have, which machine you're working with. I think I had this set up for something different. So I'm going to change that down to 0.05, a little under a 16th of an inch. It's pretty conservative, but it doesn't take long to drill these holes. So I'd rather go a little slower and a little more conservative on drilling these holes than risk either breaking the bit or something with chattering the hole or something that might happen. Okay, so we've got those set up, past depth, inside, nothing special there, no tabs. I'm not going to add any ramp. Some machines, and I'm hoping that Next Wave, they're actually talking about making an improvement to their control system Because the spiral tool path is really nice to use on holes because it basically goes down like a corkscrew. Right now on the next wave machines, that particular spiral setting slows the machine down to a snail's pace. So I typically don't use that. But some machines, depending on what brand you have, some will uh, allow you to use that. It's a great advantage. And it does sound like Next Wave on their next release of their software may actually be adding that as a feature. But otherwise, typically, since I'm only cutting a 1/16 of an inch deep per pass, and because I'm using an end mill bit, I just skip the ramps because that does typically slow down the cutting. And I just go straight to calculating. And that's the results of that. So what I've done here for the registrations, the top and the bottom are essentially identical. And then when I go to the machine, I typically skip the first one or two, depending on once you get to know your machine and your router bit. And right now for this project, I think I ended up using the 395 to get that to fit in because my router bit might have been cutting a little undersized. I was cutting a cherry, which was pretty hard, as well as the maple. So I had to go a little on the larger side. For other setups, I found myself in the 3/8 range, and that works. But that's why I like to keep this range available because I like that registration pin. I like to be able to slip it in with my finger. I might have to pull it out with the pliers, but I don't want to have to hammer it in or wrench it out. So you want a nice snug fit. You don't want it loose, but you don't want to have it too tight either. So with that part covered, let's talk more now about the roughing and the 3D finishing. As I mentioned at the beginning, these two tool paths right here are the primary.
Randy, could you answer a question?
Yeah, absolutely. What's up?
You have shown us how we get through the material most of the way. What I can't see is where you're actually plunging into the spoil board to give me my registration hole because they're both sides showing the same depth of 0.6, I think.
Great question. What you do, yep. So what you do, obviously for the registration holes at the top, you're going to take your 1/4 inch bit and you're going to zero to the top of your material. Let's go back here and let's reset that. So you're going to zero to the top of your material so that they cut it like that. Now, when it comes time to do the registrations of the spoil board, if I were to run these right now, sure, they're going to go right at the top of my material like that because that's how I set the programming. But if you zero these registrational spoil board tool paths to your spoil board, then these holes will cut into the spoil board. Does that explain it for you?
Yeah, thanks.
Yep. Yeah, so it's simply a matter of when you run these spoil board tool paths is to go ahead and zero off your spoil board and it'll drop those holes down to the spoil board. Okay, so we were looking at, as I mentioned, these two 3D tool paths are the two main tool paths that you use for 3D carving. And the first one's called the roughing. And for this one, I'm using a 1/4 inch end mill. Pretty common to use a 1/4 inch end mill for this type of work on a project this size. The basic settings are going to be, again, I'm using a 1/16 of an inch pass depth. I have a 2-horse router spindle on this machine. If you have a 3-horse, you might be able to be more aggressive. Again, depending on the kind of material you're dealing with. But I also, for this case, I go with a 70% step over. So that's more than the typical 40% because I really want to hog this out. So I tend to go less on the depth and more on the step over. Again, it's a compromise, but it tends to work out well. We'll see when we do a preview of this. I'll show you the fact that the pass depth has some effect on the 3D roughing and what you end up with and how much more material has to be taken off after that. Spindle speed, I'm going to be at about 20,000 RPMs with my machine. I find that creates a chip load here of 0.005, which works out fine. Anything over 0.002 on the shark tools usually works well. I usually target a 0.005, but there's a couple of things you just can't control with CNCs, and it's what's referred to as the acceleration deceleration. And that has to do with that, much like when you're driving your car, you've heard me use this analogy before, but if you go around a corner, you slow down and then you speed up. Well, all CNCs built into their control boxes have, I sometimes call it a governor, but it controls this slow down and speed up, the acceleration, deceleration. And when you have a lot of 3D movement like you do in a bowl where it's going up and down a lot, that acceleration, deceleration governor kind of overtakes whatever speed you set up. So I did some experiments with this recently, and as you can see, I have my feed rate set at 200 inches a minute, and that would be great if it moved that fast. But I actually went back and tested this, and what I found out is that I went down to 150 inches a minute, 100 inches a minute, and then I dropped it down to 75, and then down to 50. And at 75 inches a minute, my overall time went up like 1%. At 50 inches a minute, my overall time went up noticeably, like maybe 25 or 50%. So what that's telling me is that the governor inside that control box for this particular project is effectively giving me only about a 75 inch per minute feed rate. So even though I set this at maximum, it's going to self-control and trying to protect the machine from overrunning itself. But it ends up being a little bit less than realistic. And that's just something you have to understand, is that governor, that acceleration, deceleration has a lot of control on the 3D carving. So I'm going to go back as we go through this. I'll show you a couple places where you can look at when we're talking about time estimates, how to deal with that also. But right now, for most of my 3D carvings, to get the most out of the machine, frankly, I've been leaving it at 200, and I haven't had any negative effects from that. Now, it could come to pass in the near future when NextWave reworks their feed rates that this 200 inches a minute becomes more realistic. And if that's the case, then all of us are going to have to be careful with this, because we could get to a point where we're overrunning the machine too fast for the actual action that we want. So, but for right now, that's kind of the state of affairs. I know I've had several people ask me about time estimates and how come they're getting such wild differences in time estimates in VCarve versus what they get on the machine. This explains part of it, but again, I'll go into more depth as we go along. But that's the basic setup for the end mill. And again, you could use either Z level or raster. Raster, if we take a look at this, calculate this out. So the raster tends to follow the shape of the 3D model most closely. Now, what you look at in this picture here, this little thickness of that cut, that represents your pass depth. And so that's a pretty small amount, about 1/16 of an inch. The width of it here represents that 70% step over. So both those settings you control. And of course, as you can see, as we go up the edge here, even though our pass depth is smaller, we still end up some pretty thick spots right here. And so that's partly what you have to watch with. That's pretty thick right there. What Vcarve is looking at is that, let's open that up and take one look at 3D roughing inside it. So this machine allowance right here, this 0.02 inches, think of that as a blanket that's being left on the inside of the Vcarving, or inside that 3D carving. And so when you go inside the final one, it's this little inside corner right here. That inside corner right there to your finished shape, that's 0.02. That's what they're targeting. So obviously the top edge of this is greater than 0.02, but this lower inside edge is 0.02. And then down at the bottom here, where it's pretty flat, we have pretty much 0.02 all the way across. So again, you think of it as kind of a rough blanket laying on the inside of your carving. That's what the that amounts to. Now, I know some people that will crank that up to 0.3, 0.03 or 0.04. I don't know that I've ever found it necessary to go that thick. I've always got good results at that because, again, if we look at the 3D carving at a minimum, we've got that amount. And we actually have more than that in some of the other areas. So you can certainly experiment with that, but I found that 0.02 inches for the machining allowance in projects of this size with these bits seems to work just fine. Now we did 3D raster, Z level. The difference between 3D raster, you saw the 3D raster tends to follow the pattern. Z level gives you more of a terrace shape, as you can see right there. Still follows some of the 3D shape, but it just gives it in rings. This tends to be quicker. It does leave a bit more material in your project. And so it's kind of a toss-up which one you want to use. I have used both of them. The good news is that when we go onto the finishing toolpath, the 1/8" finishing toolpath, for this project anyway, it doesn't really matter which one you use. So I think in the instructions that I supplied to NextWave, I used the raster. Tonight, I'm just going to leave it at this 2D or leave it at the Z level setting. And we'll just go with that. We'll see what the effect is. Now, on the Z level, you have an option to do what's called a profile. And basically, that's a cleanup pass around the outside. And often, it's a good idea to do that. Again, you can either cut that first or last. That's going to depend a little bit on your material. If you think cutting it first may provide a little extra clearance for that bit, that's generally what I do. But then there's some setups where it seems like going back at the end may provide a little cleaner cut. So generally in the roughing, I don't find that to be a big deal. And then none, if you don't want to do it all, that'll even save more time, but it will leave more material for the finishing bit to clean out. Now in this one, I happen to have it set up at 45-degree raster cut. Let's take a look at that. And so there you can see how it's going at a 45-degree angle. I generally do my roughing either at a 45 or at a perpendicular to the grain. That way it cuts the grain off. There's less likelihood when you're going cross grain or 45 of it grabbing the grain and chipping a chunk out. And so for that reason, that's why I set it up that way. Not a lot of difference. You know, obviously going cross grain is going to be the hardest on the bit, the hardest cutting because you're cutting that cross grain. 45 eases that cutting a little bit, but still not going directly with it. So that's the rationale for doing that. Again, it'll depend a little bit on your material. The more likelihood, or if your material that you're using is likely to chip a lot, maybe something like, well, even some pines, oaks, some cedars, which are real prone to chipping, then certainly going cross grain makes some sense on that. Now, either way, when you have the 3D raster setup, it doesn't give you the plunge option because that's automatic, but on the Z level, it does give you the plunge option. And again, if you have the option to plunge, to ramp the plunge, I always recommend doing that. And so that just eases the bit into the material. It's always advisable to do that. Any questions about the roughing toolpath? So there we can see again.
Randy, you're using the straight 1/4-inch bit. Have you experienced with the I don't know what they're called. They're called the extreme bits where they have the ragged edges on the bits.
I have used those. Yeah. So there's a bit out there it's actually called a roughing bit. It has a serrated edge or like a rough edge on it. And that's a chip breaking. And those are useful. I personally haven't found them that essential to this kind of work. But they do what they say, and they will chop up the wood a little bit as you're cutting through the chips. So there's no harm in using those. Again, if you have one or get one, run some projects with it. If you have a straight bit, run some with that, and just, you can kind of make a decision on that. I've done some heavy duty 3D carving in it was actually in some green ash, and someday maybe I'll publish a video of it. But I was using a chipping bit on that. It was actually a 1/2 inch diameter bit with a 2 inch cutting length. And it actually did a superior job with that material because the ash is so stringy. So it tended to chop that up pretty well.
Thanks.
Randy, I'm going to do another commercial for you. I purchased a tapered bit from Woodpeckers here last week.
Okay.
I ran this project Sunday with a 4-flute tapered bit. Unbelievable finish.
Oh, okay.
And I'm running that little 1 horsepower, whatever it is, Makita router on mine. And I did speed it up and still got a fantastic finish with that 4-flute tapered.
Wow, I'm sure you did. Yeah, with 4 flutes, you're getting a lot of cutting action. Generally, with a high-speed router like that, you would go the other direction with fewer flutes, but a 4-flute, you'll still get good performance out of it. These small machines are pretty forgiving. There are ideal, we talked about chip loads and feeds and speeds and all that. There are ideal ones that are out there, but generally the small benchtop tools, no matter what brand you have, typically cannot achieve the feed rates necessary to hit those ideal rates. So as long as you're not burning your wood, you're probably pretty good. The only downside, I've had some people who turn their feed rates way down, like 50, when they're doing 3D carving. And I think that they're just wasting time doing that. You typically can go a little faster than that. So yeah, let me just pop back to the 2D view and let's take a look at something here talking about bits. So this bit here is in fact a 4-flute, and typically most of the bits I use are 2-flute. These bits here, I believe, are all 2-flute or maybe 3-flute. Most of the CNC bits you find are going to be 2-flute, some 1-flute, which are great, single flutes. But most of the Ballnose like this is definitely a 2-flute. And that's usually quite adequate, gives you a little better chip load. But if you do start shopping around, you're going to find a ton of metalworking bits out there that you actually could use in your CNC. And sometimes metalworking bits are considerably less expensive than the woodworking CNC bits, except now we're getting some imports coming in, mostly from China, of the CNC bits. And there's actually some pretty good quality bits coming in from China at a surprising price. I use a bit like this blue one here. This happens to be, I think it's, I'm not sure how it's pronounced. It's a Chinese. You find it on Amazon a lot. And I think it's like $20. The same bit from Andrud, which is an American brand, although I'm sure they're made overseas someplace, which I really like. But that bit's like $80 for the same bit. So it's a little hard to justify spending 80 when you've got one at 20 for a benchtop tool. And Amana this one is an Amana bit. I love Amana. And they're kind of somewhere in the middle. I think this is probably a $45 bit. So no harm in trying some of the less expensive ones. Some of them I have found perform well, some don't. I've tried a couple like the 1/4 inch bits. I use a lot of those. And I bought, just as a test, I bought some really, I think I paid like $9 for these bits. What was interesting is that the radius on the end was not a perfect round. So I wasn't getting the kind of results I was getting with my more expensive Amana bit. So that's one of the subtleties you may find. Okay, so let's hop over and talk a little bit about, let's go back to the 3D view. Let's just take a look at what we've got here. So we've got our roughing. Now, when it comes time to run this on the machine, you could actually save out this group. Not as a whole group, you'd save out all those individually, but I like to go ahead and cut my registration holes with that bit and then leave the bit in and then go straight to the roughing. So that just removes one bit change.
Why are you cutting them diagonally instead of on the same side?
So you could have these two right here. Those could be for one side, and you could put the other two in your spoil board. You could definitely do that. Okay, we'll take a look at the 3D finishing bit next. So for that setup, again, you're going to be using this toolpath right here. And the settings for this one, I'm using an 1/8 inch Ballnose bit. And again, inside my tool setup, I've actually labeled it 3D carving as opposed to using other 1/8 inch bits for other purposes. I don't generally use my 1/8 inch bit for other things, but I have that set up for that reason. Part of it is if we look at the details, is that notice how I have a 5% step over as opposed to some other step over. And also in this case, this one, I can actually turn this one up. I think I was doing something else with these tool paths. So let's turn this up on the speed. 5% step over, 20,000 of the RPMs. We'll say okay on that. And now something I may not have shown you the last setup is we're going to restrain the carving to the vector. So I've selected this outer vector right here. I've created a vector around the project. And that way the tool pathing will maintain itself inside of that area. On the top side, we probably could get by with using the model boundary, but on the bottom side, we have to use a vector, and I'll show you that when we get there. Now, boundary offset, what that's doing is that's taking that 1/8 inch bit, and let's take a draw an 1/8 inch bit right there. By default, when you set it up for a vector, it'll come up to the vector and cut like that. There are times when you may want, again, just like we were doing with our registrationals, you may want to cut beyond that. So in this case, you set up with the boundary offset, I'm actually moving it that much further out. So it's just going to cut a little bit beyond the main shape. Gives you a little cleaner surface in some projects, and when we preview it, you'll be able to see that. Now, in this setup, I'm only using 1/8 inch bit. We're going to come back and I'll talk more about why that is, but let me just walk you through this single setup. I'm also using a raster as opposed to the offset. The offset is kind of a spiral. Some people like to use that in shapes that are round because it does kind of go around the inside. Personally, especially when I'm using solid wood, I have found that setting up the raster, and then the raster angle is 90 degrees, which means it's going to run vertical. And notice which way the grain is running. So if your grain is running the other way, then obviously you could leave that as a 0 degree raster. But I like to run the raster with the grain because that way the bit, any machine marks are left with the grain. They're much easier to sand out than if you go cross grain. And so it generally leaves a much better finish and it's easier to sand. So that's the reason for doing that. If we look at the results, go into the preview, you can see now where that's cutting. Now, this little extra offset right here, that's part of that 1/8 inch offset that we added. Now, if I slow this down, let's preview this across. Okay, so there you can see it's going across. Speed it up now, you can see it'll go all the way across. Going with the grain, that goes all the way out to the side. Now we're going to hop back into the roughing toolpath for a minute. And there you'll notice that our boundary offset is set to 0.03. And the reason I did that was, again, to move it beyond move it beyond the 3D model a little bit and move it out this way a little bit. And that gave me room then for my 1/8" bit to come in. I like to have my roughing toolpath set up a little bit bigger than my finishing toolpath. Now, sometimes people have asked, well, how come it didn't cut deeper right here? Well, we've talked about this kind of related to this, but if we look at our 3D model, and if I turn on my modeling plane, notice where the modeling plane is. So by default, when you set up a 3D toolpath, the 3D toolpath is going to look for the 3D model. But out here where there is no 3D model beyond that vector, remember we have that vector set up? Out in this area, there is no 3D model. So by theory, there's nothing there for it to carve. And one might think, well, then it's going to carve, just drop way down to that full depth. In older versions of Vcarve, this was a problem. But now they have restrained it so that when it sees this modeling plane, it just stops at that surface and cuts no deeper if there is no model. Now in the middle, there is a model below that 3D modeling plane, so it does in fact cut all the way down. But that's the reason that we have that little flat area right here. This is actually the modeling plane surface. So it's kind of a safety to keep it from cutting too deep right there.
Now that is even if you haven't added the modeling plane, or it's just, I'm just wondering, modeling plane is an optional add.
Actually, the modeling plane is default. It's always there.
Okay.
It's not, I cannot turn on and off. The modeling plane should not be confused with what's called the zero plane. If you look right here in the lower left over here, it says add a plane component with 0 height. First, the modeling plane is, think of it like a transparent plane. It has no mass, it has no thickness. It is strictly just a surface that everything is measured from. The zero plane, if I click on that, the zero plane actually right here, if we turn this off and go back in here and turn that off, the zero plane, again, we don't see anything here, but if I go in, it actually has 0 thickness also. But let me give it just a little bit of thickness. And now you can see it looks like a piece of veneer. So sometimes people get that confused with the modeling plane. The difference is that this piece called the zero plane is actually a piece of material. And I could actually go in, and if I wanted to give that some real thickness, I could turn it into a block of wood. So that has other uses. We've talked a little bit about that in previous sessions. We won't go any further than that tonight, but the modeling plane is strictly there as a reference for the project itself. So hopefully that helps you understand the difference. The other place that you'll see the modeling plane showing up is that if you go inside your material setup, this says, it says model position in the material. Now, it's not showing it here because our model thickness is exactly or very close to 1.5. But notice that if I was actually cutting this out of a piece of material with, say, 3 inches thick, we've got lots of extra material underneath it. If we look at the right over here, this light color at the top half, that's actually our model. And notice what happens when I move this slider down. It moves it down. Now, this gap that says right here, gap above model, I put that on 1, we can actually precisely position that within there. So let's move that back to where we were. Say okay on that. Not going to recalculate right now. And again, if you want to look at the material, again, you can see how that whole thing is sitting in the material. Based on last week, we added on the bottom side, we added the bottom of the bowl, the top of the bowl, we did a negative, so it penetrated the modeling plate and went down. And then our rim is what's added on top of the modeling plate. So again, I like if it's helpful, you can think of the modeling plate as like a work surface. Sometimes I think of it like a sheet of ice or a piece of plastic or something, and you can model on top of it. You could push down through it, or you could flip it over and model on the bottom side. And yeah, it gets a little bit complicated, but it is actually, again, surprising. What you get with Vcarve, the ability to manipulate models is actually quite extensive. So for those of you who are interested in doing that, keep pursuing it. Vectric has a lot of online tutorials on this. There's other ones online as well, and just get in there and practice with it. Okay, so let's go back to the top before we move to the back and finish up here. So again, we were looking at the 3D finishing on some projects, and this is actually one that you could do this on. You could actually skip the roughing altogether. And here's how you do that. We would set up, let's go into the 3D finishing, and what, in the preview here, it's like, oh, of course it works. We go like this. But in real life, you're taking away a lot of material. Now, here's what you need to realize is that because we are set up, again, if we look at this diagram here, our 1/8 inch Ballnose is only taking off 0.0063. That's slightly over the thickness of a piece of paper. Every time this Ballnose steps over, it's taking off a little more than the thickness of a piece of paper with every cut. That's a very small amount that's being cut off of the edge, and it puts a very small load on the router bit. And that's why when you have bits like this blue one or this yellow one, you can take advantage of this entire cutting edge when you do a 3D carving and are only doing the 1/8 inch bit and just using the finishing bit. Now, a couple caveats to that. One is that it's critically important that you preview it. And we can see here that we have the router bit, this red line, the router bit is traveling over and it's going down with this little blue, light blue or aqua color. It's going into the material and then it's cutting all the way across. I'm not sure why we have this little retract over here, but as it is, you can see it's a very tiny. It's going up and coming back down, and occasionally you get little oddities like that, but that's not a concern. The concern would be when you preview this is that if you see multiple red lines going across the top of this, that means that 1/8 inch bit is coming up and plunging down, coming up and plunging down. And in that case, it would be a great risk to have that 1/8 inch bit plunge right down an inch, inch and a half deep into this material and try start cutting. That's when it doesn't work. But when you have a bowl shape like this and many 3D carvings, you could also preview it and realize that that also will allow you to do it. You could actually take one of those longer bits, and because once it engages the material, it's only taking off a paper thickness. And I do this a lot, and I've done this many times with great success and never had a problem. But like I said, you need to preview it here to make sure we're not getting multiple plunges. The other thing that's worth doing is we are getting an initial plunge. Let's take a look at this. Slow this down right here. So we're getting an initial plunge right at this spot right here, which is kind of deep. The 1/8 inch bit might be able to handle it. But here's another option you have for something like that. You could actually go into this drawing over here and you could go in and you could set up a little area like this. And now I'm going to take this area That's a little vector area. I'm going to duplicate my 3D roughing toolpath. Let's duplicate that. I'm going to open that up, select that vector, and then I'm going to go in and select my 1/8 inch bit. Let's see where my Ballnose is. There we go, right there. And now my Ballnose, my 1/8 inch Ballnose is going to be used as the roughing in that little tiny area. Double check the settings on this. Okay, here I've got 5% step over, 0.02 pass depth. Let's see, I could probably increase that to 0.3, and I could probably increase that. Let's go up to about 10 on that, just increase it a little bit. Say okay on that. And let's do a 3D raster. And let's go with the grade. So let's go 90 degrees on that. Change the size of that bit. And so now something is looking a little odd to me right there. Let's see here. It feels like I got a double shadow going on. Well, let's just try it. Let's see what it looks like here. Oh, I see what's going on. Let's stop that, reset. Oh, okay. So really what's happening is my arc is going further out than it probably has to. That's okay. I'm going to let that run. Let's just preview that. So that's going to, so basically with that bit, that 1/8 inch bit, I just use it to rough cut just that little part. Now when I go back with my finishing portion, because that's plunging all the way to the surface, it'll then pick up in that area and continue on the rest of the way. There always is some risk when you do it that way, but I've done it many times with success. So if you have a setup or a bowl like this where you could ease it in at the beginning, it certainly is worth considering because it saves you all the roughing time. Now, while we're on this page, let's take a little look at the time estimator, which is located here in the lower left. I get a lot of comments from people about this, about what, how to read this, how to use it. Now, for those of you that have a Shark machine, the rapid rate of 200, that's this. So these red lines, that represents rapid movement between cuts. And so that's what's called the 200 inches a minute. That varies from machine to machine. Vectric has no way of knowing what your machine's rapid rate is. So it's important to enter that in. And NextWave's maximum rapid rate is 200. So you can enter that in. Setup here for a 3D roughing is going to take 32 minutes. And the 3D finishing with the 1/8 inch Ballnose says it's going to take 6 hours. I happen to know it did not take 6 hours to do that. It took 2.5. And so there's a couple of settings you have to deal with. Partly, it requires you to do a little bit of testing. So this estimator, well, here you can see right here, it says 3D finishing 1. Let's see, 3D finishing with cutout took 1.4. That was a particular setup I was using, a scale factor of 4.6. So those are a couple of notes that I had to myself. This scale factor, notice that if I change this to 1, it changed our total time to 2 hours up here. If I change it to 4, it changes it to 9 hours. So the scale factor is strictly a relative setting. In general, what you're going to find out is if you're doing simple 2D cutting, like cutting out just with the profile thing, you're cutting out, so a puzzle, let's say, you're probably going to get a scale factor of 1 to 2 in that range. For Vcarving, you're going to be in the scale factor of maybe, depending on the complexity of your design, it may be 2 to 3 scale factor. On 3D carving, you're going to be more in the range of 3 to 5 on the scale factor. It is, like I said, a very relative setting depending on the complexity of your design. And so the best way to understand it is that when you do some cutting, take and log your results and kind of keep that in mind the next time you do a similar design, and you'll get yourself close to that. Unfortunately, there's no At this point, there's no better way of calculating that with Vcarve or on the Next Wave tool. Now, just from my experience, when I'm looking at, I'm going to turn this down to 3, let's say, and I'm seeing 6 hours for this 3D finishing. Something, the old smell test, something doesn't smell right about that. So I'm going to open this one up and take a look at what's going on. And I think, let's double check something. Actually, let's go over here. Let's go to edit. So I've got my 50 inches a minute. That, like I said, must have defaulted from another setup. I'm going to crank that up to 200, 100. Even though I'm actually effectively getting that much out of it, I'm going to put it there, and I just use that as a standard. And then my 5% step over. So that's what is affecting the timing then, those 3. So let's click OK on that. We'll recalculate this. Go back inside the time estimator until there. I'm more realistic on this one now. You see it says 134, and this one here says that my original one took 141. I also had an additional cutout on there, but that took about 141. So that's more realistic, and you can see I'm at a 3 scale factor on that. Now, I don't recognize this note here. 3D finishing one took 42 minutes, but here I've got 142. That might have been the roughing I was referring to. So maybe the roughing, I'd have to scale factor that up. And again, that's the thing that's a little tricky here. Each one of the tool paths may have their own scale factor to make them precise. So it's going to get you close, but it's not going to get you exact. But close is usually good enough if you're talking an hour to an hour and a half, versus 4 hours. Any questions about this time estimator before we move on? I know it comes up a lot with people.
I have a question.
Yeah.
Are there variables for the machine acceleration on the Shark machine?
Good question. Yeah, so this right here, these machine acceleration rates, some machines have those available. NextWave does not publish those because they vary. I guess they vary somewhat from machine to machine, so they have not published those. So those are not available for the NextWave machine.
Okay, thank you.
Yeah. So I mentioned earlier how the bottom side, because we don't have a lot of detail on it, we can simply use the 1/4 inch Ballnose for finishing it out. Now, here's a little something that I like to do on this bottom side. I've added what's called a clearance cut. And if we highlight it, this is just a profile toolpath. And what this is going to do is give me some clearance around the outside edge. If I run it, there you can see what it looks like. If we profile this out, that gives me a little clearance area. That way, my 3D carving that's going on the inside, I like to do what I can, because my 3D, to prevent my 3D carving bit from banging up against this long vertical side. So even with the roughing path, so the roughing toolpath, you can see how it's going to go back and forth. Let's go ahead and preview that out. So there it's going to do, and I'm doing, it's the raster setup at a 45. So you can see now how it's gone down, and it's skipped over the tabs. These are 3D tabs, and it's only gone to this area right here, and I've got that little bit of ledge. That way that straight bit is not going to bump into this tall wall every time it comes across and bang, bang. So that just is one little detail I like to add. And if we look at the settings, they're pretty much the same settings that we had on the first one. I did add this little detail here, which says avoid machine areas. Now, avoid machine areas. So in this case, if we close out of this, let's see if it shows up in this one. It doesn't always show up. But if we turn the toolpath on, yeah, what it's showing is, so this blue line going across the base is taking a little bit of material off, but once it's taken the material off that base, it's no longer cutting. You notice these red lines, it's just skipping over it. So that actually helps to save some time as well. So that's one thing. If you do have some flat areas that are going to machine flat, it's good to go ahead and add that, check that box that says skip machine areas. Now the 3D finishing, still using the same settings as before. We can see it right there. And if we preview it, it's going across the bottom. Now here's where something worth looking at. If I take a look at my 3D finishing, you see this vector right here. I'm cutting within the selected vectors. And that's important because if I were to do model boundary, it would cut over the top of these 3D tabs. And I would actually, it's not that I would lose the tab, but it would cut all the way around the outside of it, which eventually would cause it to lose connection with the rest of my material. So this is where restricting the cutting area to the vector is valuable, both for the roughing and for the 3D finishing. I also added a little bit of boundary offset. And let's go back and take a look at that. And you can see, so if we look down here now, we can see that we had our roughing was right up here. You can see a little bit of a ledge right here. That's where I stopped my 1/8 inch bit. So that way my 1/8 inch bit isn't bumping against that rough wall and the roughing bit isn't bumping against that vertical wall. It's just a little something I like to do because if you do run this and you do find your bit banging against it, first of all, it does chatter a lot. It can break the bit. But worse than that, in some situations, you may end up having where your bit, it may be actually, you may end up hitting the wall with even the, say, the collet nut, which would be a big problem. The last thing I did on this project was that I added, a grading to the bottom. In fact, let's go in here and modify that. Let's just spell that out the whole way here. Like that. And now I went and rotated it. Again, the 9 and the 0 key in your keyboard allow you to automatically rotate stuff. And I rotated it and then just positioned it. I rotated it like this because I wanted it to go with the grade. But that's up to you how you want to do it. Then on the V-bit setup, I'm using a 60-degree V-bit for this, just a simple, the one that you saw in the beginning picture. It's one of my favorite ones. It's a single flute. That one's from Onsrud. It's actually called an engraving bit. It has a slight flat on the tip, but you never see it on the Vcarving. And it does a really nice job because it's super sharp. And then one thing you want to do when you're carving on top of a 3D model is click here, project onto the 3D model. Now, in this case, there's not a lot of issue because this base is basically at the surface of the material. But notice this, that if I take this and if I wanted to carve on the side of my bowl instead, and when I do project on this, we looked at this one other time as well. I'm just going to go ahead and show you again. You can see now how it actually projects that 3D toolpath onto the surface of that bowl as opposed to just leaving it on the top. Now, if I go back and I move this over here and I recalculate that, notice now when we look at it, it's now on the bottom. So we can preview that like that. So that's how it would look up there. And then again, if we wanted to do some carving on the side, and there are some limits here depending on how sharp it is, and you'll see this. Let's go ahead and recalculate that. Back to the 3D view, and let's preview this. So there, you can see it. It's surprising how it's able to do that. You'll find a little distortion if you were to compare these two, but you could actually do that as well. Okay, then, well, thanks everybody for coming out tonight. I'll send the video out the next couple of days, as well as a registration link for the next webinar coming up. Thanks for coming out tonight.
Thank you.
Good night, everybody.
Thanks, Randy.